Hi kids, this video is a quick recap of the circuit variables that we'll be using throughout this unit. You may recall from freshman physics that there are 4 circuit variables: voltage, current, resistance, and power, and they are made up of just different combinations of the fundamental variables we've already learned about: charge, energy, and time. These 4 variables are the primary ones we're going to be using to describe what happens inside of a circuit and how electrical energy basically is transformed into other kinds of energy at resistors. The first variable is voltage, which is represented with a capital V, but remember that that's the one with all the synonyms from last unit. So voltage is often referred to as electromotive force in this unit, which is confusing because it's not a force. But those are actually the same thing. Sometimes that's just represented with kind of a cursive E, not just the letters EMF. The units in either case are joules per coulomb, or more commonly the volt. And the joules per coulomb unit should make sense when you remember that voltage is actually the amount of electrical potential energy stored up in each coulomb of electrons at any point in space. So if you have electrons somewhere in a wire, it's how much energy 1 coulomb of those electrons would have. For example, if you knew that a battery was transforming 60 joules of chemical energy as 4 coulombs of electrons pass through, then you could calculate that that was a 15-volt battery, 15 joules per coulomb. A little side note, if you see the word potential difference or potential drop in this unit, you'll remember that potential is another synonym for voltage, and so that is referring specifically to delta V, which also, of course, is measured in volts. The second circuit variable is current, which is represented by the letter I. The units for current are the coulomb every second, otherwise known as an ampere or an amp or just A sometimes. Current is similar to the way you've used current before in water, potentially. It's basically the number of coulombs of electrons every second that are passing by. One note, this is not how fast the electrons are moving, which would be their velocity. That's a completely different thing. This is like if you could count how many electrons every second or how many coulombs of electrons every second are passing past a point. That's what we're interested in when we talk about current. So for example, if you knew that in 120 seconds, 30 coulombs of electrons are passing through a resistor, then the current would be 0.25 coulombs every second, or 0.25 amps. The third circuit variable is resistance, which is a capital R. The units for resistance are really ugly. Joule second per coulomb squared, you'll never see that. It's almost always expressed in ohms, which is represented with the Greek capital letter omega. That looks like an upside down horseshoe there. Resistance is how much energy it takes to push 1 coulomb of electrons through a point in a circuit in 1 second. Or, of course, you can probably think about it as how difficult it is to get through a portion of the circuit. An example problem, we've got a 4 ohm toaster and a 3 ohm coffee maker in a circuit. Which one has more resistance? Well, the toaster, of course. It would take 4 joules of energy to drive 1 amp of current for 1 second through the toaster, and it would only take 3 joules of energy to drive 1 amp of current for 1 second through the coffee maker. The fourth variable is power, and even though we're learning it fourth and talking about it fourth, it is actually the most important of these variables, and I say that because power is the whole point of a circuit. The point is that you want to use that electrical energy to do something, and power tells me how much of that thing we are doing. I like to think about power as the total energy that is transformed every second at a resistor. But the kind of more mathematical definition is the amount of work done every second. Power is represented by a cursive P, usually, and the units of power, you may remember this from mechanics, are joules every second, or more commonly, the watt, which is a capital W. So if you have a light bulb and every 30 seconds that light bulb is transforming 90 joules of energy into light, then the power at that light bulb is 3 joules every second, or 3 watts. When you look at light bulbs in your house, they're 120 watt light bulb or 100 watt light bulb is transforming 100 joules every second into light.